Welcome to Math with Professor V. In this video, we're going to learn how to graph f prime of x if you're only given the graph of f of x, not its equation. So basically, how do you graph the derivative of a function when all you have to work with is the graph of the function? So just as a quick recap, what we should know up to this point is that when you're given a function f of x, the slope of the tangent line at some point x equals a is given by f prime of a. And depending on where you are in the semester in calculus, either you compute f prime of a using the limit definition, or if you're further along, then you know your differentiation techniques. Now, here's the idea. If we let a vary, meaning we're not holding this point fixed, we're going to let it vary, then f prime of x is a new function. And that function gives us the slope of the tangent line to the curve f of x at any x, as long as the derivative exists there, okay? So if we let that point a vary, we create a new function f prime of x, and that's what we're going to try to focus on graphing in this section, okay? And the key idea is the graph of f prime of x comes from looking at what are the slopes of the tangent lines to f of x as you move along the graph. We are moving, and we are graphing f prime of x. So to start off, we're going to just do some matching problems, and then we'll put together graphs by hand, okay? So first here, match the graph of each function, a through d, with the choices of the graph of its derivative 1 through 4, and then give reasons for your choices. So over here, these four, these are all f of x's, and then you have to tell me which ones are their derivatives over here on the right, okay? Now, I'm going to give you my biggest helpful hint. When you look at the graph of the function, see wherever the slope of the tangent line is 0, meaning it's flat. That's where f prime is going to have an x-intercept. I'll repeat that. So everywhere the graph of f of x is flat, aka it has a horizontal tangent, that means f prime has an x-intercept or is equal to 0. If it's at more than 1 point, like if it's for a while, okay? So let's just start off with a. This is f of x, and then let me see if I can figure out which graph is its derivative. So do my little trick. Start by looking, where is it flat, right? Where would I have horizontal tangents? So right here, the tangent line would be horizontal, yes? And then right here also. Later in the semester, you'll learn it's not a coincidence that these are also places where the graph has a local min and a local max. That's coming up, but that's not what we're talking about today. So don't let me get distracted. That means the derivative should have an x-intercept somewhere around here, and then another x-intercept somewhere around here, because the derivative is equal to 0 there. So do you see any of the graphs where it has an x-intercept somewhere around here and then another one here? I mean, my eyes go straight to number 2, right? Here's an x-intercept, here's an x-intercept. This is looking promising. Then, to further confirm, I'm going to check the signs of the slopes, okay? What do I mean? So on this portion of the graph, this is f of x, the slopes of the tangent lines are all negative. Do you see that? Like if you were to draw a tangent line here, that slope would be negative. If you draw another one here, that slope would be negative. So all the tangent line slopes are negative. What does that mean for the graph of the derivative? Well, the derivative should be negative, meaning it should be below the x-axis. So check on the left side of the x-intercept, is the graph below the x-axis? Why, yes, it is. See, it's below the x-axis. Okay, let's continue. Let's make sure this was a good choice. All of the slopes of the tangent lines now in this middle portion, these are positive slopes, positive. So what does that mean for the derivative? If the derivative is positive, it should be above the x-axis. Is it? Why, yes, it is. It's above the x-axis. And then same thing here, all these slopes, boom, 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 they're negative. So the derivative should be back below the x-axis. Yes, it is. Okay, beautiful. So that means we know A, the graph of the derivative of A is 2. Those are done. Okay, let's carry on, shall we? Okay, so here for B, notice this portion of the graph is a line. That means its slope is constant. So the derivative is actually just going to be constant on this entire portion of the graph. And it's going to be positive. That's important. So let's list that first and foremost. Positive and constant. What does the graph of a constant look like? It's just a horizontal line, right? And then here as well, this has a negative slope, this portion right here. And then again, right here, this is going to be a positive slope. Now, these sharp little points, they don't have horizontal tangents, right? It's very different than the graph of A. That was a smooth curve. I could draw a tangent line. I can't draw a tangent line right here. No. So these are called cusps. Hopefully you've heard that word before. Anywhere that you have a cusp, this like sharp corner on a graph, the derivative does not exist, okay? So cusp means f prime does not exist at those points. The graph is not differentiable there. So when you look at the graph of the derivative, since it doesn't exist there, you should have open circles or a hole or something going on, okay? So let's check. Do we have a graph that's made up of a positive, then a negative, then a positive horizontal line segment with some open circles or some breaks in it? Why, yes, there's graph 4. Positive, negative, positive, open circle, because the derivative doesn't exist there. So that one's done. So B goes with 4. Okay, very good. Now let's move on to C. Looking down here, do you see any places where I have a horizontal tangent? Yeah, right here, I can draw a horizontal tangent, but that looks like about it. So the graph should only have, the graph of f prime should only have one x-intercept. And then let me zoom in, notice, what are the slopes of the tangent lines here? If I were to draw little line segments, okay, boop, 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 those are all negative, right? But they're getting steeper as I get closer to the origin. As I move farther away, they get closer to 0. So these are all negative. Over here, these slopes are all positive, positive, positive. But they also start leveling out. They get flatter, right? As I get further away from the origin. So let's see, is there a graph with only one x-intercept at the origin that gets, the derivative is positive on one side, negative on the other, but it gets flatter? Yep, graph number 1 right here. So let's verify. It's equal to 0 at the origin. Notice here, the slopes are positive. They get more positive and then they flatten out. Positive, more positive, flattens out. Over here, the slopes are negative. They get steeper and then they flatten out. Negative, steeper, flatten out. So C goes with 1. Give reasons for your choices. I'm talking you through it, okay? So you can, if you need to do this as a homework problem, then just write down what I'm saying. Okay, and then lastly, D should be 3, but let's confirm, right? So do we have any horizontal tangents? Yes. Right here, right here, right here. 1 intercept, 2 intercept, 3 x-intercepts. Beautiful. And then just check the slopes. So over here, this portion, these slopes are all positive. Negative slopes right here. Then it switches to positive slopes and then back to negative slopes. So the derivative should be above the x-axis, below the x-axis. Above the x-axis, below the x-axis. Is that matching? Above, below, above, below. Perfect. So D is 3. Okay, so now when we move on to drawing the graph ourselves, I want to summarize what we learned, okay? Not only everywhere the graph of f of x is flat, that tells us f prime has an x-intercept, but we also see that everywhere f of x has positive slopes, meaning the slope of the tangent line is positive, that means f prime is above the x-axis, and everywhere f of x has negative slopes, or the slope of the little baby tangent lines are negative, then that means f prime is below the x-axis. Okay, we're gonna use this right now because we've graduated from matching and we're gonna draw ourselves. I really wanted this to be like a nice little summary box. Straighten up, there we go, there we go. Okay, all right, so let's move on. All right, so for the next set of examples, we're given the graph of f of x. Now use it to sketch the graph of f prime below. And notice here, like there's no scaling on the axes, so we're not going to be so precise about the actual x and y values beyond intercepts and whatnot. We're just going to do our best approximating, okay? So underneath, I'm just going to copy down and draw the xy axes. And let's graph the derivative now. Okay, so here's x, here's y. Always label your axes. And same thing as in the matching problems, what I want you to do first is figure out everywhere we have a horizontal tangent line. So right here, I can draw a horizontal tangent line, right here, as well as right here. So I'm gonna take those x values. And remember, if the tangent line is horizontal there, that means f prime is equal to 0. F prime is 0 there, f prime is 0 here, and f prime is 0 here. So we should have an x-intercept there, x-intercept right here, and then another x-intercept right there. Does that make sense? Okay, good. Now I'm going to go through and figure out what's the sign of the derivative, and then we'll deal with, is it getting kind of bigger, steeper, whatnot, okay? Baby steps, don't overwhelm yourself. So over here, these slopes, if I draw a bunch of little baby tangent line segments, they're all negative. Very good. Okay, so negative slopes over here. Then what's going on over here? Positive slopes, positive slopes, positive slopes. Then here, negative slopes, negative slopes, negative slopes. And then positive slopes, positive slopes, positive slopes. And they are getting steeper as we go along. So what does that tell us about the derivative? Over here, the derivative should be below the x-axis. Since the sign of all of those slopes is negative, the sign of the derivative is negative. So it should be living below the x-axis. Here, it should be living above the x-axis, and then it's 0 right at the origin. So it's going to be above the x-axis and come back to 0. Let's draw that in. So below the x-axis here, it's positive. You don't have to worry about finding exactly where this moment happens, okay? Just kind of eyeball it. It's gonna stay positive, but it sort of levels off, you know, at some point in getting more positive until it hits 0. The derivative's negative until the next x-intercept. So it's gonna be below the x-axis until the next x-intercept. And then afterwards, it's positive. So above the x-axis from there on out. And I would put an arrow. Okay, how was that one? Now, if you check the back of the book, you know, or an answer key, they might have these pieces a little steeper or whatnot, but there was no scaling. There's no precise like numbers given. So you can only, you know, be so accurate. They can't ding you excessively. All right, shall we move on? The first one seems manageable, didn't it? Look at us. Okay, example 2, I'm gonna just draw again. Coordinate plane, XY plane below. Let's see, is there anywhere that we can draw a horizontal tangent that would tell me that my derivative is 0? Right here, yes, don't we have a horizontal tangent? Okay, so the derivative should be 0 right there. Now, what are the signs of the slopes on this left side? They're positive, right? They're positive. And then they kind of start leveling out to 0. positive. So that means we should be above the x-axis, and then we level out to 0, something like that. Okay, and then this is interesting here. So these slopes, these are negative, right? Negative. And then they start flattening out. So they get close to 0, but they stay negative. So we're going to be below the x-axis. We're still below the x-axis. And then we're going to get close to 0. So we're going to level out. So we're going to get close to 0, y equals 0. But we're not going to hit 0. We're going to still stay below the x-axis. Okay? So go below the x-axis, and then now start getting closer to 0, but stay down there. It's still negative slopes. Okay, something like that. How are you doing? You know, students hate these problems for the most part because there's no like, plug and chug kind of formulaic method. You have to sit there and think, and every single one's different. So I know they can be scary. You don't know if you're doing it right. So just keep practicing. And honestly, the best thing is to just explain it to somebody else. So explain it to a classmate, explain it to a sibling or a parent, even if they don't understand what you're saying. When you walk someone through the process of how to do it, you'll understand it so much better. All right, number 3. Again, start off the same way. Is there anywhere that we can draw a horizontal tangent line? Is there? Let's see. Yeah, I think right here, again, at the origin, tangent line would be horizontal, right? Okay, so we've got an x-intercept right there. Now let's see what's going on. On the left side, these slopes, they're positive, aren't they? They're positive. They get super positive and steep kind of here. Very positive, bigger. And then they level off back to 0. So they're still positive, but then they get closer to 0. So that means we're going to be above the x-axis in the graph of the derivative. We're going to have like a little bit of a peak, get very positive, and then get back to 0. But the whole time we're above the x-axis. So positive gets very positive, and then back to 0. Does that make sense? Try to match up kind of like the very positive part with where the max is, if you can. And then what's happening on the other side? Negative slope, negative slope. Ooh, it's getting steeper. It's so negative. And then now it's leveling out. It's getting closer to 0, but it's still negative. So over here, very negative, negative, now closer to 0, closer to 0. So all of this part is going to be below the x-axis, okay? Below the x-axis, get very negative around the middle, and then level off back to 0, but stay below the x-axis. Ooh, how you doing? Good. Just keep practicing. I always tell my students, no one came out of the womb doing this effortlessly. It's just with lots of perfect practice that you too can achieve it. Okay, this one's funky. Are you ready? Anywhere that we have a horizontal tangent? Yes, right here. Okay, so that means the graph of f prime will have an x-intercept right there. Now look at here. Can I even draw a tangent line? Not really. It's a vertical tangent. So that means our derivative is actually going to have a vertical asymptote right there. And then similar on this side, vertical asymptote. Okay. What are the signs of the slopes over here? Super positive, right? Approaching infinity, super positive. Now they start leveling off and they get closer to 0. So super positive, approaching infinity, leveling off closer to 0. And then, so these are all positive slopes above the x-axis. And then here, negative, but not so negative, right? Baby negative, more negative, super, super negative. Okay. Baby negative, more negative, super, super negative, approaching the asymptote. Good? Okay. I got a couple more. By a couple, I mean 4, so I'm lying. A couple, is that just 2? Yeah. Okay, 5. Anywhere that we have a horizontal tangent? No, huh? No horizontal tangent. So no x-intercepts on the graph of f prime. Okay, let's see. But something interesting is going on here. As I get closer and closer to the origin, we have a cusp, right? The last example I looked at, when we had cusps, we had those sharp corners. They were just open circles. This one's going to be a little different because notice over here, the slopes are, what's the sign of these slopes? Yes, they're negative. They're all negative, but then they get more and more negative, approaching negative infinity, right? So f prime, the graph of f prime is going to be below the x-axis, and then it's going to approach negative infinity. That means I have a vertical asymptote right here on the y-axis. Below the x-axis, it's negative always, and then it approaches negative infinity, something like this. Let's check on the other side. These are all positive slopes, aren't they? Positive, positive, and then they get super positive as I get close to the origin, approaching positive infinity. So over here, we're above the x-axis, and as I get close to the origin, I should approach positive infinity like this. Okay, so this should look like 1 over x, basically, right? So these are all f primes, and this is f. That's been clear, right? Okay, next one, 6. Anywhere that we have a horizontal tangent? No, more cusps. Oh my goodness, more cusps for us. Okay, so let's see what's going on. This time we just have line segments. So that means the derivative is just going to be little horizontal line segments. So the slope here of this line segment is negative, right? That means the derivative is going to be negative from there to there. And I'm putting an open circle because at this point, at this point, at this point, we have a cusp, a sharp corner. It's not differentiable. Cusp. Okay, this line segment is positive, so we should have some positive horizontal line segment representing the slope. Over here, it's negative, and it's looks like it's the same amount, like the same magnitude. Like this looks less steep than this line. So this would probably be like -2, and this might be -3 or something. So I'm going to draw this lower than the other guy. Does that make sense? Just a wee bit lower. And then notice here, this one's positive, yes. And it's just about the same magnitude as this slope, right? Same steepness, just in the opposite direction. So I'm going to draw it positive, but not super high, like maybe where this guy is. Okay, I'm going to repeat exactly what's going on in just a second. So negative, positive, not super steep, not super steep. So like medium negative number, medium positive number. Positive, negative, more steep, more steep. So more positive, bigger positive number, smaller negative number. We got it? Okay. I have another example where we're actually going to compute the value so you won't have to kind of eyeball. I know that's also unsettling. So don't worry. I got you. Okay. And then lastly, we're going out with a bang. Here's a couple spicy ones, okay? So number 7, is there anywhere that we have horizontal tangents where I can draw some x-intercepts? Yeah, we do have them this time. We certainly do. Okay. It looks wild. Just break it down with the same process, okay? Like right here, doesn't it look like we've got a horizontal tangent? Yes, as well as right here. So that means f prime should equal 0. X-intercepts on the graph of the derivative right there. Okay, fabulous. Now let's check here. The slopes of these tangent lines are all negative. And they get closer and closer to 0. So they start very negative and then they get close to 0. What are the slopes here? They're negative. They start off almost 0. Then they get more negative. Yep, more negative. Then they kind of level out until they hit 0. So you're going to stay below the x-axis, swoop down, and you need to come back to the x-axis by the next x-intercept. So kind of swoop down, turn around somewhere, don't worry so much where, and come back. And then now the next portion, all these slopes are positive, yes. So that means f prime should be above the x-axis from there on out. Above, you know what, let me draw that more smoothly. Why is it like so abrupt? We don't like that. So from here it should be going up, and let me just make this kind of connect a little nicer. Okay, that's good. That was a little too wiggly. I'm not pleased. Okay, pretend that was nice and smooth. I'm just gonna put a big dot. Okay, good. Last one like this, number 8. Anywhere we have horizontal tangents? I don't see any, do you? No. If anything, here's a bizarre situation that we haven't run into. It looks like right here, if we were to try to draw a tangent line, it would be sort of vertical, right? We can't. So our derivative right there has a vertical asymptote. It's not differentiable at that point, okay? We have a vertical asymptote. What are the signs of the slopes here? They're positive, but then they get closer to 0. So the graph should be above the x-axis and then get close to 0. And like near the origin, it's very, very steep, almost infinity. So f prime's graph should approach positive infinity. It's going to look like this. Yes. And then pretty much same thing on the other side. So these slopes are all, yeah, they're positive. Oh, they're positive. And it approaches positive infinity. Let me write that down. These are all positive slopes approaching positive infinity. So above the x-axis, and as you get close to 0, go to positive infinity. We're done. You know, I'm really embarrassed about this one. That was just ridiculous. Hold on, let me at least fix this little piece here. Okay, that's better. Good. All right, the last one I've put on an exam many, many times. Here it says the graph of f of x in the accompanying figure is made of line segments joined end to end. Graph the derivative of f. So right here you have f of x, and I'm asking you to graph f prime of x. And I've given you some values so you can actually compute the slopes and not just eyeball everything, okay? So notice here, the graph of f is just made up of line segments. So the graph of f prime is going to be just horizontal line segments because the slopes on each of these little baby pieces is constant. So let's figure out the slopes on each of the line segments, and that's going to help us put together the graph of the derivative. So looking here at this first line segment, you can do y2 minus y1 over x2 minus x1, but why don't we just count rise over run? It's so much easier. So from here to here, we rise 1, 2, and we run 1, 2. Positive 2 over 2 means the slope here is 1. Let's repeat for the next line segment. This time we rise negative 1, 2, 3. We run positive 1, 2, 3. Negative 3 over 3. This slope is negative 1. Next piece, we rise 1, 2, 3, 4, 5, 6. Run 1, 2, 3. So 6 divided by 3. M is 2. And then maybe this last one you can tell we don't rise at all. We just run. 0 over any non-zero number is 0. So slope is 0 right there. Okay, so now we're going to graph the derivative and just match up the heights of the derivative with what the slopes are for each of the intervals. So look, from x is negative 5 to x is negative 3, I'm going to draw the derivative at y equals 1. So from x is negative 5, 1, 2, 3, 4, here's negative 5, to x is negative 3, I'm going to draw the derivative at y equals 1. And remember, we put open circles because the derivative doesn't exist at those sharp corners, at the cusps. All right? Now, continuing the next piece, from x equals negative 3 to x equals 0, we have this portion. And the derivative is equal to negative 1 right there. So I'm going to draw a line segment This -3 is in my way, okay? From -3 to 0 at -1. Open circle, open circle. Next piece, from x equals 0 to x equals 3, the slope of that line segment is 2. So the derivative, I'm going to graph at y equals 2 from x equals 0 to x equals 3. And then the last piece here, this slope is just 0 from 3 to 6. You have to match up the x values. So from 3 to 6, slope is 0. Did I go too far? 3, 4, 5, 6. No, perfect. All right. So hopefully that clears things up. Now, you can also use this concept when dealing with particle motion. So if someone gives you the graph of the position function and they ask you to graph the velocity, velocity is derivative of the position function, so you would just apply the same principles here. Or if you're given graph of velocity and you need to graph acceleration, same idea, okay? Just practice. Remember, first thing, find horizontal tangents. Those are the x-intercepts on the graph of your derivative, and then you just start checking the signs. Where is it positive? Where is it negative? That means above the x-axis, below the x-axis, and then every now and then you've got like a spicy asymptote in there. But hopefully you should be ready, okay? Give the video a thumbs up, subscribe if you haven't already. If you need more help on Calc 1 topics or other topics, I have full video lectures organized into playlists on my channel. So do take a look around. I'm sure you'll find it really helpful. And you can also follow me on Instagram, TikTok. One of my TikToks is blowing up, you guys. I'm so excited. And Twitter, Math with Professor V. I love you all. I'll be back soon. Bye.